For the next part of the video, we're just going to go over some Delta Math questions to make sure we understand what they're asking and how it relates to the notes. So if we read the directions, use the definition of continuity to determine whether the function f of x, graph below, is continuous at x equals 4. These questions are very analytical, which means you're going to have to look at a picture, understand the question that's asked, analyze what's going on, and come up with your answer. And you're often going to have to do it using the correct math language. So first thing to recognize is this is a piecewise function. It consists of actually 4 different pieces. 1, 2, 3, 4. And you might even argue a 5th if you include this solid dot. Down here at the bottom, they ask you to fill in what is the limit as x approaches 4 from the left. So over here, this is 4. I'm going to come in from the left. One second. Not sure why I did that. Okay, so that means I'm traveling right here where this cursor is moving. So coming in from the left, the graph is approaching 0. Coming from the right, which is the second blank, the limit as x approaches 4 from the right, is going to be coming down this pathway here, which it looks like it's approaching -5. Okay? These two numbers are not the same. So when we start looking graphically at limits, in order for the two-sided limit to exist, which is what they're asking for here, the individual left and rights need to be the same. Okay? So as you can see, it's now filled in 0 and -5. It's determined that the limit doesn't exist. So then they're going to ask you, well, what is f of 4? Well, if I ask you for f of 4, I don't see any solid dots anywhere in here, which means the f of 4 does not exist. Therefore, it can be stated that the function f of x is not continuous at x equals 4 because the limit as it approaches 4 does not exist. Okay, so what they're getting you to do is they're getting you to kind of step by step go through and say, well, what's happening to the left? What's happening to the right? Is it approaching the same value? And does that same value, is that what the function evaluated it at is? So let's look at another one. Typical question. The graph of the function f of x is shown below. State all the values of x between -9 and 9 for which the function has a removable discontinuity. This is a vocabulary question. A removable discontinuity is the same thing as a hole. Okay? It's a single value hole where the function approaches from the left and the right to the same location. There's only one place for that, and that's right here, where I'm circling with the cursor right now. This is a jump continuity, where there's a break in the graph, and you can clearly see a jump. As I come down, it looks like it would be continuous except for this location. This is where the x value of 3 shows a discontinuity that is removable. That's what you would type in. Now, this question is not only asked but also answered here. I went straight to the answer key to make sure that you were clear with what we were doing. The graph of the function f of x is shown. State all of the values for which the function is discontinuous. So they want to know how many pieces of the graph are there. Okay, so it's discontinuous right here at -7. Notice the green area, because I have a jump continuity. I have a break in the graph. It's discontinuous at -6 also, because notice now I have a break in the graph that's a hole. Even though I have a point up here, it still is not smoothly connected. The next break in the graph is at -3. And then finally, I have one that I haven't seen a lot of except in the notes, which is the break that probably indicates a vertical asymptote right here at 3. Okay, so at negative 7 x value, negative 6, negative 3, and 3, we have discontinuities.